Okay, today is about binomial probability. So we're going to be doing basketball, and basketball is a uniquely American sport. Was it John Naismith, I think was his name? Basically, an American invented it, and then it started off with just as simple as a basket up there, and they'd actually have to climb up and get the ball out because I get how it makes it a little more completion. It does, instead of just going through the hoop, it actually stayed up there, and you're like, "Go, you got it in." But obviously, they didn't score that much back then when they first started the game because they weren't that good at it. But anyway, it's kind of cool that we started basketball. Anyway, so basketball player has at the end of the game has got two shots. Now, if he's a 90% free throw shooter, I think we all know he's likely to make both shots, but there's a lot of pressure at the end of the game. Can we factor that in? You probably could. If you were in a super advanced sports class, maybe they even have factors for choke factors on certain players. In other words, some players are really clutch. They can handle the pressure. They actually like to have the pressure because somehow it makes them play a different level. There were some players who actually want the ball in the last few seconds because that gives them the surge of confidence because they're so good. Anyway, but there's other people that choke because, like, oh my gosh, there's so much pressure, even though they're normally 90% free throw shooter, because there's so much pressure to win the game, it's all on them, that they might actually perform way worse. Well, we just do probability as random, as in you don't have this player that's going to choke, or it's just like if there was a machine that made 90% of the free throws, the machine isn't going to care that the game's on the line. The machine would just go up there and shoot, and it would make 90% of the time, right? All right, so we're going to have to assume nerves of steel, they're just going to make 90% like normal. But do you get that when they have these two shots at the end of the game, they could either hit or miss the first shot, and then they're going to get another shot, and they're either going to hit or miss that shot. And then when it's all said and done, they either had a hit or a hit miss or a miss and then a hit or a miss and then a miss. You do not have to write out the whole chart. You do have to write out the four things at the end: hit, miss, hit, and miss, using a calculator to go with 85 and 15. I want you, don't write out the whole chart, to tell me what this answer is, and that, and that, and that. Just get those four things with the calculator, with decimals. Now I'm going to show you how there's a formula that could do that so much quicker. And this formula is called the binomial. Bi means two. The reason it says binomial is because there's only two things that could happen. You either hit the shot or you miss the shot. This kind of formula does not work. Three things that could happen, like I get a red marble or a blue marble or a green marble. If there's three things that could happen, this formula doesn't work. But I have to admit, a lot of things in life are either it works or it doesn't work. You know, that's a binomial situation. I made it or I missed it. I got the job, I didn't get the job. There's a lot of things in life that are binomial like that. All right, so right now you are calculating out a decimal for this by going 0.85 times 0.85, and you're getting that. You're getting the other three, so we have a total of 4 decimals that you're finding right now. All right, I'm going to pause for a second while you figure that out. Okay, you're going to use the dice of destiny to figure out who's going to be answering first. It's row 5. Person 3. Everybody keep your numbers going, but row 5, person 3 in this case is you. Could you tell me EH? What'd you get for that top one, HH? And I'm going to round them to 2 or to 3 decimal places, 0.07. Would it round to 7.2 or 7.3? 0.72. All right. Oh, it's 72? 0.72? Are you sure? Okay, just making sure. All right, then 0.72, and then I want the third decimal place. What I mean is 0.72, and then what's after that? 0.723? All right, thank you. All right, can we agree on 723 as in 72.3% chance? All right, now think about this. Back to the basketball player. He's pretty good. Do you get there's a decent chance he would make both? Yeah, and what is the chance he'd make both? 72% chance. It's not an 85% chance. That wouldn't have made sense. All right, now there's also a pretty large chance he will make one and miss one. I mean, that's the actually pretty likely scenario. So make one, miss one, and that's the top row. I'm sorry, it's this, and then it's this, and let's see, row 3, person 2. What did you get? LP. 1275, which I'm going to round to 128. And if that one's 128, pausing for a second. Okay, so if it's 0.128 there, here's the kicker. Think about this. Do you get, if this one's 0.15 and a 0.85, that it's the same thing being multiplied together? And so therefore this is the same thing? This is really important. 0.128. That these two are the same. Let me just hover on that thought for a moment. I'm going to go with the highlighter here. That and that giving me that is the exact same thing as that and that giving me that. There's two different routes that give me the same exact probability. All right. That's what our formula is going to help us figure out. Okay, the last thing is miss, and that's just two simple multiplications. Row 4, fifth person. And that would be the guy who just got here. We're going to have to default to the back person. Yes. Miss. Point what? Oh, 29. Awesome. So that's about 3% chance. Really, if the guy's really good. Oh, didn't get that? I need to get other people's check on that. No? Okay, what did you get when you multiplied 0.15 times 0.15? Okay, it's okay. We all make mistakes. What? 023? All right, thank you. Probably just typed one little number wrong there and messed it up. Oops, and now I'm in highlighter mode. Hold on. I want to get to regular pen mode. 0.023. Did I get that right now? Okay. So now, what did we just figure out? Trees are a pain in the butt to make. Trees can answer everything. Those are good things to remember because, like, you have a big probability test coming. And if you had time, you can make a tree for every problem and figure it out. But they're such a pain to make that it'd be great if we had a formula that could do this kind of stuff for us, and we do. So let me show you. I'm going to keep the same exact problem up and show you how I would have done a question about like this with this formula. Okay, let me show you what the question would be. We can use the chart to answer it really easy. And then I'll show you how I could have used the formula instead. Here's the question. At the end of the game, guy's got 2 shots. What's going to be the probability that he makes one of them and misses one of them? That's really a pain to figure out unless you have a chart or this formula. What's the probability he makes one and misses one? Do you get that that's not just this top row? It's not just this, because there's 2 ways he could make one and miss one. Okay? So the answer is there's 2 ways. It's either he did hit-miss or he did miss-hit. Either way, he made one and missed one. So then it's this or this, and what do you do with ors? You add them together. You add those ors. So it's 0.128 or this other 0.128, and then my probability went up because he can either do it this way or he can do it that way, and making it go up means you're adding them. So 0.128 plus 0.128. Final answer, 0.24 and then 256, 0.256 when I add these together. I had to probably take 12 minutes on a test to make all of that chart perfectly so I could answer that question. That's a pain. Watch how fast I can do it with binomial formula. This is the good part. Pay attention. All right. So if I have something see something, you know how to do that, right? If I said he had 2 shots and I'm going to choose to make one of the 2 shots, you get it? Didn't matter which. You're just going to make one of the 2. Right? You make one, miss one. He made one of the 2. Then, what were the 2 probabilities involved? 0.85s, that's making, and 0.15s, that's missing. How many makes did we have? 1. How many misses did we have? 1. And I put that in my calculator, I get the answer of 0.256. I'm going to say that again. I had 2 shots, and I'm going to choose that he makes 1. What that does, this part right here, that tells me how many routes there were. There was this route, or there was this route. Do you get how there was 2 separate routes? Guess what 2C1 is? It's 2. Because there's 2 routes that would work. Okay. Then, on each of those routes, what are we multiplying? 0.85 and 0.15. 0.85 and 0.15 are the 2 things we multiply. If you followed that setup, if this is about 90% free throw shooter, he's a little better than the other guy, and he's supposed to make 2 of them, what number would go here? He's going to make 2, and therefore, if he makes 2, he has to miss 1, right? What number do you think goes here? 2 90s. That makes sense? He's got a 90% make, and he's going to make twice, 2 90s. And therefore, how many misses? 1. Do you get this can be done in the calculator? All right. And of course, that squared could be done in the calculator times that. All right, so let's set up another scenario. I have, just see if you can set up this thing. C with a parenthesis. Get that written down. And now here's your question. And you already know how to do this. It's not that hard. Don't overthink this. Let's say the guy's a 95% free throw shooter. He's really good. And he gets 10 shots at the end of the game. What's the probability he will make 9 out of the 10? %, free throw shooter. Gets 10 shots. Why would you have so many free throws? Well, because they keep following you. If it's a close game and your team's behind, you're supposed to follow the other team to make the clock stop. And then they have to prove it, so to speak, by making their free throws. And if they miss their free throws, you get the ball back, and then, all right. So, all right, tell me what you think the setup is. This is row 1, person 4. That's you, OF. What do you think? He had 10 shots. We're choosing that he makes 9. See how 10C9 is like 10 choose to make 9? Okay, then keep going. You're doing good. How many of those 95s do we have? In other words, how many makes do we have? 9 makes. Keep going. Correct, because that's the miss percent then. And notice that this plus this equals this. No, it doesn't. It equals this. There we go. And the other thing you can notice is that this will always be the same as this. Those 9s will always be the same. And then these 2 green ones at the end, these will always add up to this one here. Okay. I bet you're ready for one of the toughest questions on the test then. And so here's an example of one. You've got somebody in soccer who is got a free kick at the end of the game. They have a percent in the past. They've made 75% of their free kicks. Let's say that they get 2 free kicks at the end of the game. What's the probability they'll make 1 out of the 2 free kicks? Exactly 1, not 1 or 2. I mean, obviously, we all know if you're on their team, you'd like it if they made 2. That'd be good. But the question isn't that. The question is they make only 1 of the 2. Say that one more time. They're 70%, 75% in soccer. They got a free kick. In the past, they were a 75% free kick scorer. Then, what's the probability they'll make 1 out of 2 free kicks? Could you do this by making a tree? Yes, it'd be really slow. This should have been fast if you knew what you were doing. How many of you are already done with the setup? See, almost everybody's done, so that's really quick. All right, so something sees something, and then 2 sets of parentheses. Let's see if random person has it. It is row 5. Person 4, back person. That would imply we had 2 chances and we wanted to make 1. That's exactly what we had. Good. Then, this is the make percent. Yep. And one of the reasons, that's always going to be equal to that. Keep going. And this and this together always have to add up to 100. I never mentioned it, but I think you figured it out. Good. And then to the what? And why could you know that that had to be 1? Even if you didn't understand the problem setup, you could say what plus what, that's equal what? Yeah, 1 plus 1 has to make that. All right, cool. That's it. Now, I'm going to show you one more really nice slide that's been done that, here, it's all worked out, which is really cool. And I want you to look at this problem and see, do you get that this is 3 chances, but wait a minute. You've always done free throws and stuff, Mr. Server. This is baby cats and dogs. How could that be the same? Well, you're still either going to get a dog or you're going to get a cat. And this is apparently you're at the animal shelter. And more people pick dogs than cats. That is true. It's just a fact. They're just more popular. So then, if we go dog, 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 you could have done this with a chart. And if you had the chart sitting there, there's really no point for the formula. Except, it's still faster. Even with the chart all made, this formula is still way faster. I want you to read this over and make sure you understand where this formula came from for this problem. Pause for a second. Let me just read it quick. Any questions? Then I'm going to change the problem slightly and see if you know what to do. We're going to leave the tree the same because that's a lot of work to make that much of a tree, all right? But I'm going to make the problem a little different, and you set up one of these guys for my scenario. Okay? What's the probability that they pick at least 1 dog? At least 1 dog. Hint, there's an easy way and a hard way to do this. You can use the formula, you can use the tree. What's the probability they're going to pick at least 1 dog? Well, a good start would be, what's the probability that they pick one dog? What's the probability they pick one dog? Well, and that's 3C1, 0.57 to the 1, 0.43 to the 2. If you wrote this, that was a great start. That's the probability of picking one dog. But I said at least one dog. Do you get that then I have to also figure out the probability they pick two dogs? And then the probability that they pick three dogs? And it's either they pick one dog, or they pick two dogs, or they pick three dogs. And you add them all together. Oh, there's a much faster way. What could you do? Yes? You think you know the answer to that question, or you have a question? All right, so hold that thought a second. I need to finish this thought. What could you do instead of figuring out this one, which was one dog being chosen, or the next one, which would be two dogs? Here, I'll make it two dogs, two and then one. Or I could do three dogs chosen. Choose three. That's a 3. This is a 0. Does that mess things up? No, anything to 0 power is just 1, so it doesn't hurt anything. And I have to do all of those and then add them, or there's a fast way. Yes, I think you got it. Yes, you can figure out the probability of getting 3 cats. Let's do that, because you might be like, what are you talking about? The question was about dogs. But if you find the probability that you have 3 and you choose 0 dogs, 0.57 to the 0, 0.43 to the 3, do you get that that's the probability he's going to choose 3 cats? And then, what? Yeah, take that and subtract it from 1. Because they all have to add up to 100%. So I'm either going to figure out this, and then the one above it that I can't even see, and add them all up, or I can take 1 minus the probability of no cats. This probability is a whole bunch of, wait a minute, I think I might have just, I have 0 dogs, 3, yep, oh, I did it right, good. That's 3.3s all being multiplied. Because this part is just a 1, and that part actually is just a 1 also, because 3 choose 0, there's only one way to do that. So therefore the answer to that part's 1. This is a 1, this is a 1. And so it's basically a bunch of 0.43s multiplied together. Why? Because that's the cats. They're all 0.43, 0.43, and 0.43. Multiply them together, you get your answer. All right. So one more. Here's a nice, clean, typical test question. The Spaceball one. Do it with this, but I'll answer your question first, yes? On the last problem, yep. What about the C? Okay, the C is always how many chances you had. In this case, we had 3 chances to pick a pet, okay? The bigger number always goes there. Do you get that? Why that would be a 3? Are you not getting that part? I can explain it more. All right, so if I'm asked the question about like free throws or dogs or cats, I got to know how many times I'm going to do this thing. How many times am I going to be shooting a free throw? How many times am I going to be picking a cat? And the bigger number of those goes in the front. Okay? And then I choose out how many I want to focus on, like making basketball shots, or in this case, picking dogs. That's the thing I'm focusing on. Then I say, how many times did that thing happen? Okay. Good enough? Move on. So here's this baseball question. We're going to get a certain number of at-bats in the game. Do a something, see something. And I would always make this the positive one, like make, or the thing we want to happen. Make that first. And this is not get a hit or miss. All right, see if we can do this. To get it set up, actually see if you can type it in the calculator right, because that's what you'll have to do on the test. You might be able to make the formula, but you don't have to put it in the calculator. That'd be bad. If you need to borrow a calculator, come up and do that now. Okay. So big picture, you should be getting ready for a test here. This is one of the last 2 things. I got to teach you this today, which I think most of you guys, if you get this right, you've got the idea. Get your, let's see what written down. Make sure, oh, you got it in the calculator, okay. So then the only other thing we have to teach you is tomorrow I teach you a thing called expected value. I'll give you just a preview of that. It would be like, you're going to go play this casino game 40 times. Well, you know the casino games are rigged against you. But do you get if you play something 40 times, possibly you might win once out of the 40 times at least? It's like, how much money should you have left? It's using probability to figure out value in like money. So let's say it's you are a life insurance company, and you have a whole bunch of people insured. The dream world for the life insurance company is that nobody dies, because then they don't have to pay any money out, right? So you can actually do probability involved with money that tells you the value of something. So for instance, if you're a life insurance company, what's the probability that at the end of the year you're going to be ahead or behind money-wise? I mean, they try, of course, to set it up so that they're ahead. They want to make money on their life insurance deals. And they're very skeptical if they have somebody sign up for life insurance and then immediately use it. You've probably seen cases where you have like a husband-wife combination and one of them buys life insurance, lots of life insurance on the other person, and all of a sudden they die in strange circumstances because the person's trying to collect life insurance money by, yeah, like we were just trying to take a picture and then suddenly she fell. So anyway, there's insurance companies look into those things really close because they want to make sure that, you know, beyond, of course, just the justice in the world thing, they want to make sure to protect their investment because they're going to lose a lot of money. They want to make sure it was legit. All right, you should have set this thing up and said 0.295 is his make percentage. And this may feel wrong, but you actually, if you're a good baseball player, you're way more likely to miss. You're a, was it 7 or 6? 705? All right, thank you. I'll mess up in my head for a second there. Making sure, yes, that is correct. Good, then you're a 70% misser. You're actually if you're batting 300 in the in any league, you're doing pretty good. So, all right, so then we have how many shots at this? 10 at bats. This was 10. Did you have that as a 10 this time? You asked it before. Good, you got it now. All right, then how many do we want him to make? Or in this case, hit. All right, exactly 4. Not at least 4. That would be way harder. If they asked us for at least 4, we'd have had to done 4, or 5, or 6, or 7, or 8, or 9, or 10. You'd have had to add all of those up. A separate little C thing for each one of them. This is for 4 hits exactly. And then that means he makes 4, and he logically then misses 6. Raise your hand if you set that up right. Awesome. Do you get if we wanted, he'd be really happy if he got 4 at-bats, right? Because that increases his batting average. But wouldn't 3 hits out of 10 actually still increase his batting average? So he'd be happy if he got either 3 or 4 hits. So then, this or 3 hits. It takes 2 seconds to tweak it. Make another one for 3 hits. Let's see if you got this one. I said he'd be happy if he did 3 also, so that's 10C3, and then 295 with making 3, and then 705, and he had 7. There we go. These have to add up to 10, and this is the same as this. How many of you feel like you get this stuff? All right, it's just a cool formula that saves you a ton of time. Can you imagine what the tree would have looked like for this? If you would have had to make 10 separate at-bats. I mean, just the first 2 at-bats would have looked like this. There's at-bat number 1, and there's at-bat number 2. And if we had to keep doing that to make it all the way out to 10 at-bats, Just think about how awful that would be, and then try to find all the ones where he makes exactly 3. There's a lot of ways to do that. He could have got the first 3, of course, and then missed everyone after that, or all these different combinations. But this formula, the binomial formula here, would do it so much quicker. All right. Last one about our baseball player dude. Do you get his worst case scenario is he has no hits out of 10? That's the only thing he's really, really, really scared of. Let's say he's having this game and his or a couple games probably for 10 at bats, and his family has flown in for the weekend, and he's like a little scared that what if I miss every single at bat, I get no hits. What's the probability of that? No hits. Just set up a C thing for that. He gets no hits. What is the probability he gets no hits? Can C what? 0. And you still always use 0.295 here and 0.705 here. And now it's just 0 hits means 0 of these, and that means they were all 10 of them were misses, so there's a 10 there. Actually, put that in your calculator, see what you get for an answer, and hint, that part is just 1. That part is just 1. 1 times 1 times that. Because why? Because if it was a tree, we'd be doing the part of the tree that's got all misses, which is 70, 70, 70, 70, 70, 70, and so it's 0.705 to the 10th. There's 10 of them. All get multiplied. Very low probability of that then, isn't there? What was the number? 0.030. Anybody verify that number? Okay. So is that a 30% chance? No. What percent chance is that? About 3% chance. Then, what if I ask it the other way? The other way is, at least he'll get 1 hit. Do you get how it's sort of like the opposite of? It's sort of like me saying, 60% chance of rain tomorrow, so 40% chance not rain, right? Well, if it's a 3% chance he's going to totally biff and get no hits, then can't you just say it's a 97% chance that he will get? Yeah, you just take 1 minus the chance of the thing you really is scared of, which was a 3% chance. 1 minus 0.03 would give you 97% chance that he's going to get at least 1 hit while his family's there. Okay, that's the ins and outs of the most complicated kind. Now, the second most complicated kind is what we did yesterday. What we did yesterday was CC over C. I just want to remind you, here is a typical card question that has CC over C in it. Just set up one of these with me, and then we're done. Okay. On the card questions, there was 52 cards in the deck. Just a reminder, you're going to need that number. You get dealt, this is called 7-card stud. You get cards, just 7 cards, and you can't trade any in. It's simple. You just get dealt 7 cards. Okay? What's the probability that you will get a dream hand of 3 kings, 2 queens, and anything else for the last 2 cards? You could get anything else for the last 2 cards, but 3 kings and 2 queens. Hint, separate it out into kings, queens, and one more C for, what do we call it? Other. I'll say the question one more time. You're going to be dealt 7 cards. Deck of cards, in case you've forgotten, has 52 cards in it. What is the probability you would get this dream hand of 4 kings, 3, did I say that? No, I said 3 kings, right? 3 kings, 2 queens, and 2 other cards. That would be an awesome hand, because that's what's called, anybody know, in poker? 3 of this and 2 of that? Full house, very good. Got some poker players in here. I love playing poker. I still play sometimes, but always had a lot of fun doing that. Okay. Did you have 4, choose 3 for your kings? Raise your hand if you're smart enough to do that. Okay, good. Then it's 4, choose 2, and then it's, well, let me do the bottom, because Mr. Cervero said do the bottom first, because it sometimes helps. Well, how many totals are there? This is what's possible. There's 52 cards, and we're going to choose out how many total? 7. So do you get how you can use this then? Because this plus this plus this has to equal this. So do you get how you can use logic then to figure out that last spot? Because if they have to add up to 52 and we already got 8 of them, then I can take 52 minus 8 to figure out that last spot. Yes, question? That's not what I asked, though. I know what you're saying. In poker, that'd be great, but then we'd have to do this scenario, or, which would mean plus, a whole nother one of these CC overseas. You know what I'm saying? So, yes, you could change this problem to be a much more complicated question. At least 3 kings would mean 3 kings or 4 kings. So you'd have to do this whole thing, and then you'd have to say or, and then you'd have another set of like 4C4. So anyway, the top would be added. The bottom is just simple. That's one of the reasons I say to do it, is because it's a simple part. All right, so did you figure out then that this must be 40 something? What was it? 44? Anybody verify 44? All right, good. Then, how many cards of that kind do we want? The others, we don't care how many. No, we have to have exactly how many. We need this to add up to 3 and 2, and this number here has to make it 7, so therefore it had to be a 2 right there. Raise your hand if you set that up right. Awesome. Okay, so that's 2 really difficult days of probability in a row. Tomorrow's one more kind called expected value. And that's where we figure out dollar-wise. And it's really not that hard. You take your probability and you times it by the amount of money involved. And then you add them all up. So I'm going to give you that ahead of time to see if anybody remembers this for tomorrow. Expected value, it's the probability times the amount. And then if it's this or this or this or this, you add them all up. Probability times the amount, and then you're just going to add them all up. That's what it boils down to tomorrow. That sounds scary because they're word problems, but you just got to figure out probability. You times it by the amount of money involved, and then you add up all the scenarios that could happen. Either this will happen or that'll happen, and since it's or, you add. All right. For tonight's homework, it is a worksheet. Let me pull it up here with you so you can see. And it's a little one of those ones that's going to be kind of weird. I can't just say do evens. And warning, we haven't put stuff in a while. And it'd be a good day to get something in the gradebook tomorrow. This is not a Monday, and etc. So here is our worksheet. I guess people at home probably would rather have me slide it over here. See it better? Okay. And in this case, because of how the worksheet's designed, I'm going to say you should do problems 1, 2, and 3. Problems 1, 2, and 3. All right. Notice problem number 1, it's just set up the formula. You know, like 2C. In fact, let's do the very first one. You toss in the coin 7 times. Ooh, right away I know something about my formula. It's 7, C, and then it depends on how many I want. And we're focusing on how many heads there are. Do you get there's heads and there's tails? But the thing we're focusing on is the heads. So this number here, I'd 7 choose 0 because we're focusing in on the heads. Then heads is the first one. Again, there's no reason heads is more important, but they tell us to focus on the number of heads. And this other part is the tails. You don't have to label it with heads and tails every time. And then what's the probability of heads? This is a weighted coin. So 65% chance of heads, 0.65. So therefore, what percent chance of tails? 0.35. You actually multiply that out with a calculator, but be smart. Do you know anytime you choose 0 of something, there's only one way to do that? You just don't take any. So that's a 1. Anytime you're choosing 0, it's a 1. Yes? I get you. I am skeptical that you could actually get that to be so that it would actually land a certain way but there are trick dice, trick coin. How would you actually weight it? My theory would be you'd have to design it simpler than just a thin coin. You'd want it to be kind of thick-ish and make one. Oh, with a die, it's actually, they drill. There's a multiple ways you can do it. Sometimes they will actually do it in a really simple way, which is change some of the numbers on the die. And you wouldn't even notice, because when you pick up a die, do you look at every side and make sure it's got 1, 2, 3, 4, 5, and 6 on it? People usually don't. So if you do, well, you would catch a person who was trying to cheat you that way. But there's another way on dice is they drill in and they put little weights on one side so that like they drop in a little weight so that the one side of the die is heavier than the other, and that's more likely to stay down then. So whatever's on the other side of that is going to be up, and therefore you can weight dice so they are much more likely to come up a certain way. But it's still not guaranteed if you just weight them. So, all right. Back to final answer on this guy. We wanted 0 heads and 7 tails. So final answer to get the probability of it would be you're going to go 0.35 to the 7th. And I think you'll catch on to the pattern after a while. They go pretty fast once you get the pattern. Oh, 7 choose 1. 0.65 to the, got to be the same as that, 1. And then 0.35 to the, these two together have to add up to 7, so that's got to be a 6. Boom. I move on to the next one, and the next one, and the next one. In fact, has anybody already finished this problem? All right, so there's some people that are already done. I know the typing in the calculator part is a bit of a pain, but that's the main thing you got to learn today is that formula. It'll make you practice it a lot of times. So you're just doing problems 1, 2, and 3. That's all I got for you for today.